You can show thumbs up. Good morning. Is I audible to all of you? Okay. So my name is Amit Gupta, and as assistant professor from Sahyog College of Management, welcome to the workshop of EDA analysis. And here we go. Basically, everybody knows that what exactly mean by data science. Now, from the last few years, you might have heard data science has been blooming so well, so much that it has created a revolution in the field of technology. That data science is one of the blooming content or the blooming technology which is going to take all over the technology in the upcoming. So, as a part of the data science, EDA is one of the first process of the data science where data science goes, where data science works. Okay? So, EDA is one of the first steps, and the full form of the EDA goes here as exploratory data analysis. It goes as exploratory data analysis. Now, the question comes here: what exactly mean by exploratory data analysis? Why it is being used, and who uses exploratory data analysis? तो सबके दिमाग में यही एक क्वेश्चन है कि EDA है क्या, EDA यूज क्यों होता है, EDA का मतलब क्या है और कौन यूज करता है. तो EDA का फुल फॉर्म जो हमारा है, that is exploratory data analysis. It is used by data scientists to analyze, investigate data sets, to analyze and investigate the data set and summarize the main characteristics. For example, you might be knowing data. Agar Facebook, you might be knowing Facebook is one of the biggest company. He is multinational company and he is one of the biggest turnover company. He turn over lots of money into a year. This turnover is very big. So why it is? Because Facebook, there is lots of data available into the Facebook. Okay. There are lots of data available into the Facebook. There are lots of content available with the Facebook. Twitter. Now Twitter is again upcoming uprising company. Why? Because it has lots of data. Lots of data are available with the this thing. So the more the company has the data, the more powerful it will going to become. Okay. So the basic thing is like that way. The company which has more data means it has more turn. So EDA analysis is nothing but it is an exploratory data analysis which works on the data. So in this EDA analysis, in this complete EDA analysis, data scientists use this EDA data. EDA means the completely formatted data to take out inside something, to take out insight from that raw data. And after that, data scientists use it for machine learning, use it for artificial intelligence, your Ola, Uber, everything work on this EDA analysis. So apart from this, now we are going to see the four main libraries of the EDA, that is Numpy, second is Pandas, third is Seaborn, and fourth will be Matplotlib. So we will be going across these four properties called as Numpy, EDA, Matplotlib, Seaborn. These are the four main libraries where the data scientists actually work, or which is the required library which is needed for the EDA, that is exploratory data analysis. So let's start. And the first topic we are going to cover here is what are Numpy array. Okay, what are Numpy array? The first library over here is Numpy array. See, basically ये जो EDA है ये कुछ नहीं है. For example, आपने कभी देखा होगा कि आप रेलवे स्टेशन जा रहे हो, कोई आ रहा है आपको कह रहा है कि ये फीडबैक फॉर्म है. आप किसी रेस्टोरेंट में जाते हो तो आपको फीडबैक फॉर्म आता है. बेसिकली अगर आप कॉलेज में भी हो तो आपको एक फीडबैक फॉर्म आता है. वो फीडबैक फॉर्म किस काम का है? वो फीडबैक फॉर्म आगे डेवलपमेंट के काम आता है, डेटा कलेक्ट करने के काम आता है. बट एवरी टाइम अगर कोई अपना कंटेंट शेयर करेगा, एनी टाइम एनी पीपल इज गोइंग टू शेयर देयर पर्सनल कंटेंट, इट्स नॉट कंप्लीटली नेसेसरी कि वो रिवील में ओरिजिनल ही डॉक्यूमेंट देगा या वो प्योर कंटेंट देगा या वो प्रॉपरली आपको इंफॉर्मेशन देगा. हो सकता है वो इंफॉर्मेशन गलत है. So there are many times the data is has ambiguity, it has some gangue particles. Certain type data is null. So to clean all this data and to do various kind of activity, various kind of operations on this data, this is called as basically exploratory data analysis. And the first library which we come across in the EDA is Numpy. So what is Numpy? Numpy is nothing. See, num means numerical. Num means numerical, py means Python. Okay. Hope you are able to see my screen. I am using a Jupyter of Anaconda's software. I am using Jupyter notebook. So here I have written it as EDA1 the topic, and where we are starting with a NumPy array. So our first library is NumPy, and which is nothing but a numerical Python. Means we work with a various kind of numbers, and it is a Python library. So that's why it is called as numerical. Now, NumPy is a Python package that stands for numerical Python. It is a core library for scientific computing, which contains a powerful n-dimensional array of n-dimensional. The array can be, everybody knows, apart from when we are going to EDA, everybody knows what is array. Array is nothing but a collection of a similar data. So array could be a single dimensional, array could be a multiple dimensional, array could be n-dimensional. So that is kind of a thing where array is work with. Okay, and NumPy, we basically work with such kind of a thing. We work with a numerical Python. Okay, it is a core library for scientific computing which contains a powerful n-dimensional array object. Now, where is NumPy? Now we got to know what is exactly meant by the NumPy array. But now the question comes is where we use this NumPy. So we basically use NumPy array provided for integrating C++, different kind of data, different kind of software we are using, different kind of languages we are using. From that, in their article content, their array content, we are use this NumPy to integrate from this software. Okay? It is also useful in linear algebra, random number capability, k-nearest algorithm, different kind of things where NumPy has been used. Okay? NumPy array can also be used as efficient multi-dimensional content for generic data. Now, actually, let me tell you what is exactly NumPy array. Here comes the proper scientific. That is, NumPy array is a powerful n-dimensional array. It is nothing but it is an array object. It is a powerful n-dimensional array object which is in the form of rows and columns. Obviously, because the array is in the form of rows and the columns. We can initialize NumPy array from nested Python list and access its element. Everybody know what do you mean by the list? Yes, it is a set of data, okay, in the into the Python. In order to perform this NumPy operation, the next question comes to our mind is how do I install NumPy? Now we know what is NumPy array. It is a numerical Python which is dealing with an array which is a kind of n-dimensional array which is used for integrating C++ kind of a tools. Okay, all kind of a generic data. Now we know actually it has rows and the column. We can initialize NumPy array, nested thing. We can do everything. Now how to install NumPy? Okay, you have to go to your command prompt, your Python command prompt, your Python IDE command prompt, and you have to type a word called as, you have to type a statement pip install NumPy. जब तक आप अपने IDE में जाके pip install NumPy लिख के execute नहीं करेंगे तो आपके यहाँ पर जो NumPy है वो रन नहीं होगा. Okay, so you have to write pip install NumPy. ये लिखना है आपको आपके Python के IDE में जाके. We can do the simultaneously. आप simultaneously ये लिख सकते हो pip install NumPy. See this pip install NumPy. Once the initialization is completed, then you can use different IDE. For example, if you are using PyCharm, then you can write here import NumPy as well. Okay, I'll show you. See, I have already installed the pip install NumPy into my library. So I will write here import NumPy as NP. Import NumPy as NP. Because NumPy is a big word, as an alias, we are using it as an NP. As an alias, we are using it as an NP. See, I just run, see it run over. Because it's not giving me any output. It's already been installed into my IDE. That's why it has been not giving me any kind of an error. So let's start with our practical session for the NumPy and what exactly first we'll see what is NumPy multi-dimensional. Okay, we're going to see here what is exactly multi-dimensional multi-dimensional array. Okay, multi-dimensional array we are going to see. Now already we have imported import numpy as numpy, import numpy as np we had done. Now I'm taking here as a variable. Now instead of using numpy, I'm using np, and I'm going to create an array, np dot array, and now I'm going to use the array over here, the 1, 2, 3. I have used here a np dot array 1, 2, 3. I had given a set of an array, and what I'm doing here, I'm printing a over here. I'm printing a. Okay, and I just run it. See, I got 1, 2. Okay, now I got this as a one-dimensional array. Everybody knows this is a single-dimensional array. 1, 2, 3. It does not contain any row. It does not contain anything. It is a single-dimensional array. Okay. Now, if it is a single-dimensional array, let's see what is a multi-dimensional array. Then A is equal to np dot array. Now, I'm going to take for here one more array. With this 1, 2, 3, and then what I'm going to do, comma, between this. Create an array. Comma 4, 5, 6. I created the array over here, and I'm going to print 8. Okay, I got two-dimensional array. That is 1, 2, 3, 4, 5, 6. Means it has a rows and a column. So that is called as a multi-dimensional array. So this the first one which we are created, it's a single-dimensional array, and the second one which we are created, it's the multi-dimensional array. While this is happening, many of us wonder why do we use Python numpy if we already have a Python list. Now सबको ये क्वेश्चन आ रहा है, जब हम लिस्ट ही बना रहे हैं 1, 2, 3, 4, 5, 6 इसको हमने जो लिस्ट ही बनाया है ऑलरेडी सारे काम लिस्ट अगर कर सकता है तो हम पाइथन का numpy पैकेज क्यों यूज करते हैं? So let us understand by some examples. I'll show you one example. See now here I am writing here one code. Import numpy as np. Now I'm again importing a tally. And which is from the system. So I'm writing the sys. Now I'm taking a variable s over here. I'm taking a variable s over here, which is going to give me a range. Range is a function. How much range you want? So I'm taking here 1000. I'm taking here 1000. S equal to range. And what I'm doing, I'm going to print. Now what I'm going to print, I'm going to print sys dot get size of. I'm taking here get size of. This is a method I'm doing this get size of 5. I'm writing here 5. I'm getting size of 5 times. I am multiplying the length of s. S is nothing but my range. I'm multiplying the length of the range. Okay. And I'm just printing over here. I got 2000 or 28,000. In the same line, I'm again taking one as a d equal to np dot arrange. Now this range is a function from the list. Now arrange is a function from the numpy. Okay. I'm taking here 1000. I'm taking here 1000. And now again I am printing something. Print. What I am printing here? D dot size. D is the size of the range size into D dot item size. Dot see 4000. Now the above input, the above output, whatever the above output, because we have done the two same thing, but once I have done it by using a list kind of a thing. Second, I have done by using a numpy kind of a thing. The above output shows that the memory allocated by the list, that is denoted by S, is 28,000. This is actually the memory occupied by this list. Okay, is whereas the memory allocated by the array is just 4,000. Is just 4,000. You can see the major differences. This actually differences is just to show that Python NumPy array versus list. Okay, you can call it as array NumPy array versus list. It's nothing but just to show how less memory, how convenient, and how fast NumPy array is there with respect to the other thing. When you do the same thing with the NumPy, with this kind of a thing, for example, with the list, to see how much memory is wasted. The same thing you can done in a 4,000. Now, what is the major difference? There are major difference in the less memory, major difference in a convenient way, major difference. It is very fast as compared, because obviously the code has been concise. The code had come to the shortened as writing so much of the thing. So that's why we have the NumPy array. So this example proves that NumPy array is less memorable, convenient, and fastest. The very first reason to choose NumPy is less memory as compared. You can write it directly. If anybody asks you why you are using a NumPy into the EDA as a library, the first reason to choose NumPy Python is less memory as compared to the. Okay? So in this way, we can find it out how the list is not better than NumPy, or NumPy is more convenient than. Okay. Now we'll move and we'll find out the, now here we have written the print A. We have written here print A. Now what I want to do, I'm just writing print A dot end. I have written here end. Sorry, I have written only end. And I'm just writing. It is giving me 2. Okay, what does actually it is? What do you mean by ending? Ending is nothing but to find the dimension of the array. Ending is nothing to find the dimension of the array. I'm going to write out here so you can note it down. Ending to find the dimension of the array. Okay. So ending is nothing but it is a short form for the end dimension, and you can see it has given me 2. It has given me 2 because it is a 2-dimensional array. And if I write here ending over here and I just run it, it's giving me 1 because it is showing me that it is a 1-dimensional array. And here I have 2, so it is showing me it is a 2-dimensional array. It is a 2-dimensional array. Now my voice is clear, ma'am? Now it is clear. Hello, is I audible to all of you? Okay. Now we'll describe the various NumPy operation. Now we'll come to the NumPy operation. Okay. Now we'll come to the NumPy operation. Now we'll see what are the different kind of NumPy operation. Okay. We'll discuss the various attributes of NumPy. Now we have just seen the one. End dimension. Now we'll see ND array dot shape. We'll see ND array dot shape. This is again a function into the NumPy. ND array dot shape. Nothing but returns a tuple consisting of an array. It returns a tuple consisting of array dimension. It can be used to resize the array. Okay, it can be used to resize the array. For example, I'll show you how it can be done. Now what we'll do, we'll take import NumPy as NP. We are taking import NumPy as NP. A again equal to NP dot array, and we are going to create an array. And now we are going to create an array. 1, 2, 3. Okay, I have created here 1-dimensional array. One more array I'm going to take 4, 5, 6. Okay. So we have created here array. Now what I'm going to write here, print instead of this we have to take one variable. Again we are going to take here a dot shape is equal to a comma 2. A dot shape is equal to are printing here A. We are printing here. Now what we have done? We have taken a numpy. Okay. We have taken a numpy. We have created an array, two-dimensional array, and we have told that we need three rows, two columns. We have given the shape 3 row, 2 column. See, 1, 2, 3, 4, 5, 6. First row, second row, third row, first column, second column. 1, 3, 5, first column, 2, 4, 6, second column. So in this we can specify the shape. In this we can specify the shape. Similarly, it can be done in another way also. It can be done in another way also. Just put it here at a comment. I'll show you the another way. How the another way? I'll take here B is equal to A dot. We have one more function called as B shape, and it can be written like 3, 2. Again, this function we can use, and we can print B. We can print B. And then I'll run this. See the same output. Either you can do A dot shape, which is equal to 3, 2. Okay, or either you can do reshape function, which is A dot reshape 3, 2. In this, you have to use the same variable, but you have to be equal to 3, 2. Here you are using a different function which is assigned to the variable, and then you are printing. So both are the same. It is used to give the shape or reshape or change the thing particularly. You can do 2, 3. See, 2, 3. I have just 2 columns, 2 rows, 3 columns. Okay, 2 rows, first row, second row, 3 columns. 1, 2, 3, 3 columns. So shape, again, if you want to give the shape, give it like that way. If you want to reshape, you can use the reshape. Okay. So in this way, whether you have given the array previously, and if you want to reshape it, you can reshape it. Okay. Now the next operation we are going to cover is evenly spaced number. We are going to see evenly spaced number. I'm writing here hash an array of evenly spaced number. Evenly spaced number. Okay, you can also write it down. And how I'm going to do that? Similarly, again, import numpy as np. Okay, now A is equal to np dot arrange. And we have a function called as an arrange, and I'm going to give it 24. I'm going to give it here 24, and then print A. Print A. np dot arrange 24 print A. I'm going to run it. See, I got 0 to 20. Arrange is nothing but it is that attribute which returns the number of array dimensions. To give it 24, it is going to return that. To give it like 30, it will going to return that range. See, till 20. It is going to give you that range, 0 to 20. So in this way, we are going to use an arrange function. If you want evenly spaced number, if you want the even spaced number directly from this to this, you can directly give a function called as an arrange, which is again a numpy function, and you can use this. Okay. So now I want to check. Once I have created here, now I have created. Okay. Now what I'll do here, I'll write one more thing. That print. Write here one more thing. Print A dot ending. I'm printing here dimension. Let's see. It's giving me it's a one dimension. Okay, it's giving me as a one dimension. Now what I'll do, same in this, B is equal to reshape. To whom I should reshape A. I have to reshape A because A we have the arrange function. B is equal to A dot reshape, and we want two dimensional array with 4 row, 3 column. 2 dimensional array, 4 row, 3 columns, and I'm going to print the B. To print here. Okay, cannot reshape because it says not evenly. What we'll do, we'll take it here as 24 because the number is in not proper order. See, now see, we can see the output. First, we have taken the arrange 24 evenly spaced number we have taken, so we got 0 to 23. Now we are printing how many dimensional array. So we have printed n dimensional. This is one dimensional array. Now we have reshaped that. We want two dimensional, two arrays. See, now this two array with 4 row, 3 column. One is 2. Already we have 2. Yes, 2 arrays are there. 2 arrays are there. How many rows? See, 1 row, 2 row, first row, second row, third row, fourth row. Again in this first row, second row, third row, fourth row. How many columns? 3 columns. See, 1 column, 2 column, 3. 2 array with 4 row, 3 column. Arrange evenly spaced number. We got it. We printed how many dimensional are there? We got it 1 dimensional. Then we need to change the dimension. And to change the dimension, we have used a function. Okay? How many arrays we want? We want 2 arrays of how many rows? 4 rows, and how many columns? 3 columns. So we got 2 arrays with 4 rows and 3 columns. Okay? Now, again, if we have seen this, now what we are going to do here, I'm going to print one more thing. Let's print what it gives me. A dot item size. A dot item size. Let's see what it's giving me for. You can calculate the byte size of each element. See this item size, what does it do? I write here, calculate the byte size of each element. Calculate the byte size of each element. It is going to calculate the byte size of each and every element, that is 4 bytes. Every element can have a memory of 4 bytes. So with item size, you can calculate the byte size of each element. Okay. Now, for example, there is one more thing, and I am going to use over here. I can write here print A dot type. D for data type means what are the type of data. A means the array, because basically what array you are using. D for data type means what is the type of the data you are using. D types, and then I am writing integer 32. So what kind of data type it is? Integer 32. How many size of each data? 4. How many dimensions are there? 2. How many rows are there? 4. How many columns are there? 3 columns. See, very closely look at this code. You are doing a Numpy, then you are arranging it into 24. 24 evenly spaced number you have used, random numbers of even space. So you have to use a word called as an arrange 24. So you got 0 to 26. Then I check कि ये कितने dimension का array है. So जब when I check, I got it in 1 dimension. I check it, it is a 1 dimension. Okay. Then what I do, I change the size. I want to change the size of this. I don't want it 1 dimension. I want to change the size. So when I change the size, I got it 2 array with 4 row, 3 column. So I use reshape. Then I check that every element, whatever the element it has, how many bytes it has, how much memory it contains. So I use a function item size, and then I check that what are the data type of this element. So I use D type. So I got it as integer 32. So this is a basic thing. Okay. And here we have just created an array without giving us as a number. So if you previously can see, I have given the number, but here I have not given the number. I have taken the evenly spaced number. So for to take an evenly spaced number, I have an arrange. Then to check the dimension, I have n dimension function. To reshape it, I have reshape it. To check the byte, that I have item size. What are the data type? I have. So this is also a functions present in the number. Now what in case if I want to create a empty array without giving anything, I am not going to give anything, not going to give a range also. And if I want to create an empty, okay. So what we can do? We can again write import numpy as entry. They have written import numpy as entry. X is equal to entry dot empty. I have written here empty. The function called it as empty. And I am writing three columns, three rows, two columns. And then what I'm going to give here, data. Data is your data. You write here in. Write here in. Write here print. See, empty. I have not given anything. See, यहाँ पर मैंने अरेंज दिया था उसे और 24 नंबर आई हैड प्रोवाइडेड फ्रॉम माय साइड. ओके, so he knows that कि मुझे 24 numbers लेने. Just in case अगर I have not provided any, you don't want to provide anything, then what you can do? So how you can do that? Okay, so you can use empty. So you are not providing anything, you're providing empty. Then you have three, 1, 2, 3 row, 2 column, and data type you are providing it is as int. So you provide the data type int and you are printing over X. See, I got it like this. See, I got it like this. Okay. Hello, hello, hello. I'm audible now. Hello, I'm audible now. I'm audible now. Hello, I'm audible. Okay. Now we'll. Sorry for the interruption in between. Now we'll move towards the next part. We have seen how we have created an empty array over here. See the empty array we have created over here. Now we can see that previously we had provided as an arrange with 24 as a number, but here we have created an empty array. Now, what if we want to create an array with zeros? Now, what if we want to create an array with zeros? So, what we can do? Similarly, we can write it over here, import numpy as np, x is equal to np dot zeros. We're going to write here zeros. And how much we want to write it here 5. And then 5. And then what we are going to do over here. Import numpy as np import numpy as np x is equal to np dot zeros. And let's get 5. 5 0. Then print x. Print x. See 0 0 0 0 0. So whenever he is presenting here, default type is float. Whenever you are going to print a 0, default type is float. Default type is float. Can you see? See where we have printed here zeros. First, we have done arrange by giving it as a 24 as a number. Then we have written here empty. He is taking it randomly itself as a number, and we have given d type as an int. Here we have not mentioned any d type. We have written here only zeros. He has given us the 5 zeros, but it is giving us enough float. It is giving us enough float. So that is by default. So that is by default. He is giving us in a 0. He is giving the zeros in a float because by default that is given. Now, if we want to give it as a different data type, we don't want it as in a float, we have to write it here d type is equal to np dot int. Write here np dot int. We'll close this and see. Let's see the float has been removed, the point has been removed. Okay, similar things you can do if you do not want it as 0 and if you want it as 1. Similar thing you can do if you do not want it as 0 and if you want it as 1. Simple, instead of this, again import numpy as np x is equal to np dot 1. What I'm writing np dot 1. Simple. Then print x. Print x. See 1.1.1.1.1. Again, it is giving us in a float. Okay, by default type, it is float only. If you want, you can change it. If you do not want, you can keep it like this way, as I shown you how to change. Now, if I want np dot 1, I have written here 5, so he has given me a single dimensional array. What if I write 2.2 comma 2? Okay, I have written here 2 comma 2. Okay, and let me first take here a bracket, and then 2 comma 2. Here, what we are writing to d type. We are taking here d type equal to int, and we are closing this. And if we are going to close the d type as an int, see 1 1 1 1 1 1 1. We have written here 1 1 1 1. Okay. So in this way, the thing has been 7. In this way, the thing has been done 1, 1, 1, 1. Now zeros, it is giving us zeros. Once it is giving us the 1. Okay, empty 3, 2. We have written 3 rows, 2 columns. So all the thing here we learn here is that if you want to arrange the thing, that we have to give it is there are 24. If you want to see the dimension, we have used n dimension. If you want to change the shape, we have written here as shape. If you want to change the size of each element, we have item size. If you want to check the elements what are present is of which data type, then we have your D type. Okay. So in this way, we are able to do here many. Hello. So in this way, we have created the thing. Now 1 and we have written here zeros. So 0, we have created here 5 0 and created here 1 and that 1 1 we have created. Okay. So in this way, there are certain operations which we have done. Okay. Now we are going to see NumPy array from existing data. Now we have seen here how we have seen here different kind of an operation, different kind of function. Now we are seeing here NumPy indexing and slicing. How we should index and slice. Now, so far we have learned what is NumPy. So far we have learned how the data has to be created. So far we have learned how the arrange function is going on. So far we have to be seen like how empty data is created. We have seen how data dimension can be changed. Now we will see how to do indexing and slicing. I'm writing here indexing and slicing. Now we are indexing and slicing. Import NumPy as NP. Import NumPy as NP. A is equal to NP dot arrange, and we have written here 10. Okay. S is equal to slice. What we are doing? We are slicing. S is equal to slice 2, 7, 2. 2, 7, 2. We have done here slice, and then what we are doing? Print A and we are printing S. Because S is our variable. A slice 2, 7, 2 and A 2, 4, 6. See, slice means you are slicing the thing. So from where its syntax goes like this way, where it had started, where it goes stop, and what are the steps? Where it start, where it stop, and where it step. Start, stop, step. Start from second till 7, and he is taking step 2, 2. So that was after 2, it is 4. After 4, it is 6. It has taken the gap of 2, 2. So that is 2, 4, 6. So that is called as slice. That is called as slice. Now, what if I want to only just print a single item? What if I only want to print a single item? What I'll do? Simply, I will take here B is equal to A of 5 and print B. B is equal to A of 5 print B, and I'm going to run this. See, I got 5. Or if I'm going to 7, this is 7, because already we are taking out a single. We are taking here single. In this slice, what we are doing, we have given the start, we have given the ending, and how many step position we have put in. Here, what we have done, we have taken the single position A array, and I have given the position on the 7, 7. Okay, so in this way, we have done the indexing and the slicing. Here, we have done the slicing of the single item, and here we have seen how we can put it in a range from starting position to end position, and how many steps we need to check. Since item starting from index, okay, you have to then see the slice item starting from the index. So that you have to check it out. For example, in this only what I'll do, I'll give you one more example. For example, print A 2 colon. I have written here. This is the slice colon, okay, and I'm writing here and I'm running. See 2, 3, 4, 5, 6, 7, 8, 9. Because we have done till arrange as 10. So we started from 2 and the slice. So after 2, every element which is present. So after 2, every element which is present is 3, 4, 5, 6, 7, 8. So this is the element which is present after. Okay. Now we have seen how to start arrange, already seen how to slice it, starting, ending, and how many steps, how to take out the single position, how to start from a particular position till the end. Now we will be seeing slice in between. Now if we want in between, same program, I'm going to write it here, print A 2 in between 2 to 5. 2, 3, 4. See, we got it 2, 3, 4. Okay. In this way, we are able to create the slicing as well as we are able to create the single position. We are able to create the slice with the step also. So in this way, indexing and slicing can be done with respect to the array. With respect to the array. In this we can do so far. Now, what if I want to check again for the multi-dimension? Now we will slice the array from the index A01. Okay, A01. Now again we'll see import numpy as empty. Import numpy as empty. Now taking A is equal to np dot array. np dot array. I'm going to create an array. Inside the array, I'm going to create 1, 2, 3. Again 3, 4, 5. Second array, 1, again I'm going to take 4, 5, 6. See, I have taken here 3 arrays. Okay, np dot array, I have created here 3 arrays. Okay, and then what I'm doing, I'm just printing A. Print A. Let's first see what it prints. Let's first see what it is. 1, 2, 3, 4, 5, 4, 5, 6. So these are this kind of an array is present over there. Now, what we are going to do, we are going to slice that. In this, now we have seen in single dimension. Now we are going to see multi-dimension. Here we are going to now yes, we will slice the array from the index. Now see print A1 colon. Print A1 colon. See, I got 3, 4, 5. 3, 4, 5, 4, 5, 6 means I have eliminated obviously 0, 1, 2, 0, 1, 2. So I started from 1. I have started from 1. I have started from 1. So basically this is going on 1, 2, 3 and started from 1 means first row, second. After the first, the second. Now note it down very carefully. When I am using here this dot colon, this is called as slice. This is called as slice. Now I'll give you more example. Now we have already taken this array. Okay, import numpy as an array. We have taken 1, 2, 3, 4, 5. Our array. It is our array. So what I'll do here, I'll do one more thing. On this only, I'm going to do one major operation. What operation? What we want to return array of items. Return array of items in second column. We want it from second column. We want it from the second column. So how we will do? Second column, no, not row. Obviously, our array is always defined by row and column. Okay. Now here it is second column. We do not want it as second row. We want it as second column. So how we'll do print A. Now very carefully remember. Now we are working with multi-dimension. So instead of using a single colon sign, we will be using now ellipsis. Ellipsis means 3 dots. Ellipsis means 3 dots. 1, 2, 3. Okay. And what we want? We want it from the second column. Second column means one column because 0 will be the first column, 1 will be the second column because it starts from the index position 0. Now we have written print A like this. Now see, we got it. 4, 5, 6, 2, 4, 5. We got it. 4, 5, 6 and 2, 4, 5. We got it here. Just a second. 4, 5, 6, 2, 4. Second column we want 2, 4, 5. 2, 4, 5. Now we'll do one more thing. What we'll do one more thing. We will print all the items from the column onwards. We'll print all the column onwards. We have got only one column, but from the first column we want all. Only it has given us the first column. So now we want from first column all. So we'll do the first ellipsis, okay, and then one, and then colon, because after that we want all the elements. Now see, we got it. 2, 3, 4, 5, 5, 6. 2, 3, 4, 5, 5, 6. All the columns. Okay. Now, what is this kind of thing we have done? We have seen indexing, we have seen slicing, we have seen into the single dimension, we have seen into the multi-dimension. Now we are going to see a new topic called as Numpy string function. Okay. Numpy string function. Everybody know what is exactly mean by string. Okay, the string is nothing but a collection of a character or the something. The following functions we are going to use here into this string as to perform vectorized string operation. What we are going to do? We are going to perform vectorized string operation for arrays of numpy.string, numpy.string, or you can say numpy.unicode. For the string, it can be done. Okay, so we'll see. We insert one more cell and we insert. So there are based. Now, whatever function we are going to use that are based on the standard string function in Python built-in library, or all the built-in function we are going to do. So we are going to first see add. We are going to first see how add is going to work. What I'm going to do, import numpy as np. We have seen. Now what we are going to do, print concatenation. And obviously concatenation example. When we do the concatenation example, and then again I'm just printing something. Print np dot cat dot add. Here because we are using add function, we are using add here. Hello. One more word we are going to use here. And we are adding hello. And here we are making a word here. And what can one more thing. Let's first see how what it do. Concatenation example, hello. Concatenation example here is in hello. Hello. So he has done the concatenation with the add. We can do the concatenation. Okay. Now we'll see one more example. But what we do first, we need to print a new line. Let's print and then see print. What we are going to print now? np dot cat dot add np dot cat dot add hello. Hi. Hello. Hi. We have created here this in the above. There is only one word. Now we are going to create a two word. Let's see how it maps, how it concatenates. Hello. Hi. And taking a word called as Amit. We are taking the word called as Manish. np.cat, we have taken two words. Hello, hi, Amit, Manish. Hello, hi. Hello, hi, Amit, Manish. Here in the first, we have taken only one word. In the one set it's one word, in the other set it's one word. In here we have again taken the two set, but in a one set we have taken the two words. Let's see. See, hello, Amit. I means zeroth position compare with zero. First position concatenate with first. Zero concatenate with zero. First concatenate with the first. And in this way, we have done here the concatenation example that can be done by using the add. That can be done by using the add. Now we'll see one more example called as a center. We'll see one more example called as a center. We will see what center do. This function returns an array. Okay, for example, if you want to print something to the left hand side, if you want to print something to the right hand side, okay, so that completely it is going on how many things is going to be done by that. We'll see. Import numpy as no need, we are doing in the same thing, so we will continue directly with the print. Okay, what we'll do, print lp dot cat dot center, because the function is this, so we'll do the function. What we are going to do, hello, we are going to give a word called as hello, and how many we want? We want 20 means width, how many width we want, and what character you want to fit. So we'll write fill cat, we want to here this, we want it here start. In this we want it here start. Okay. See, start means this is the array, this is the width, and this is the fill cat. Okay. And let's see. See, hello. See, you can see 10, then hello, then 10. Means this hello word, and there is a 20 star, and you have to fit this word in the center of the star. So I have written here star, 10 star, then hello, then here. So this center function, which is used, input string is centered and padded on the left and the right with the fill character. Okay, this can be done. So again, one more function we can see it is called it as capitalize. Okay, it returns a copy of the string with only the first character capitalized. It will return only the first character as a capital. So we see here the function capitalize. Okay, capitalize function means print np dot cat dot. Again, if the function name is capitalized, so we will write here capitalize. Hello. How are you? Hello, how are you? We'll do one more thing. Hello. Only the first hello is capitalized. The first word, first letter is capitalized. H is capitalized. Rest all are small. Okay. So that is the function capitalize to capitalize the first character of the sentence. First character of the sentence. Then again we have a function called as title. Now let's see what title do. Let's see what title. What we'll do, we'll copy the same statement over here, and we'll see with this what title. Instead of char dot capitalize, what we'll do, we'll write here title. Title. We'll run it. And you see, first capitalize has capitalized only the first letter, but title has capitalized every first letter of your statement. See, hello, how are you? H is capital, H is capital, E is capital, U is capital. When you are using capitalize, only the first letter is capital. So that is the thing, capitalize. Okay. Now let's see one more example. The word it contains lower, obviously means lower character. Okay. Instead of char capitalize, what we'll do, we write it here lower, and we'll give here one capital word. Let's see what it do. Hello. And see, it has lower all the word called as hello. Now, what similarly it is upper also, you can use the upper function also. Now, I want to show you one more function which is important, as called as script function. Okay, what I'll do, I'll write it here script, and what I'll do, it has to be given a certain different way, and how I'm going to do here. Suppose I'm going to give here a word for a show. Okay, one word is a show. Second word I'm going to give here as a roar. Second word I have given here as a roar. Okay, and then I have given here the word A. I'm going to give here the word as A. Okay. Dispatcher take from 1 to 2 position, but when given, okay, there are certain mistakes in the position, and we have to see the position, how the position is working. So script I have given here a show and a road, and then I have given here A. Okay, let skip this, and I'll definitely go you. But after this, I'm going to show you one more example of a script. Okay, so this script actually show. Okay, just a second. Show A and then done. See, it has removed the word A. Again, it has going to give me one more word, a road. And if I run, okay, we can give only 1 to positional argument, we cannot give more. So yes, so we have to remove this. Or what we'll do, we'll take it like this, and then see what it happens. Ashok arrow. So it has removed the word A. And what it does, whatever word you are going to give, it is going to remove that. It is going to remove that word. So in this way, we have seen the certain script function. Okay, and we have seen many kind of a function which are there listed above from starting to end. We have seen what is numpy array. We have seen what is numpy array used. We have seen how to create a single multi-dimensional array. Why it is use numpy rather than the list because of the memory. How to change the shape, how to check the dimension, how to check the item size, how to check the data type, how to create an empty with a specific set of data type, how to create a zeros. If you are not giving in a zero, then it is something called as float. But if you give the data type, you can specify the data type. Okay. Similarly, we have seen indexing and splicing. There are many indexing and splicing functions available: single dimensional, multiple dimensional, and different kind of string function. Okay. So far, I hope you have noted it down. Everybody has noted it down. Okay. Once noted down, you can put me into a chat. Whatever doubt you have, you can put into the chat. Whatever doubt you have.